Hello students, welcome back. I hope everybody sufficiently reviews the method of integrating factor. Let's go. We went through these two problems and maybe one more. Okay, the very first thing we have to do is to make it into the standard form. So z prime plus pz equals to f. That's what we want. So divide by 1 plus t squared. So this is gonna be negative 2t over 1 plus t squared. And then this plus 2t, we need it in the other side. And then again, we need denominator 1 plus t squared. Does it look okay? Let's increase the font because we have fractions here. Okay, all right. Let's find out the integrating factor. I'm missing the negative sign. Okay, what's the antiderivative? You can use integrating by substitution. What do you get? You get negative log of 1 plus t squared. Is that right? Take the derivative, this whole thing goes to denominator, and by chain rule we have to multiply the derivative of the inside 2t, and we have negative, so we have negative there. Okay, but before doing anything, let's move this negative sign. Okay, that's enough. Why did I move this negative sign over here? Because of the experience, as a matter of fact. You see, the integrating factor is e to the q power. And if we have something related to the logarithm, then that'll kill off the exponential. But we're not going to have the cancellation if there's something in between. Whenever we have something, negative sign or any coefficient, we should move it upstairs so that exponential and logarithm cancel each other out. So that's log of 1 plus t squared to the negative first power. Now, if you cancel out this exponential log, then you're going to get 1 plus t squared to the negative first power here. So eventually you're going to get 1 over 1 plus t squared. That's the integrating factor. Okay, multiply the integrating factor to both left-hand side and right-hand side. What do you get? You have z times the integrating factor. So times z, and then that is equal to multiply the integrating factor, this negative 2t over 1 plus t squared squared. Okay. Let's take the antiderivative. And again, because of the fractions, I need bigger font. So, okay. So, take the antiderivative, 1 over 1 plus t squared. Z is equal to antiderivative of this. Is this something you can calculate easily? Well, I have 1 plus t squared down here, and its derivative is up here. So yes, you can use integration by substitution. You're going to get 1 plus t squared to the negative first power. Let's see. Take the derivative. Okay, that's what you're going to get. Let's check. Take the derivative. Negative 1 comes out. We have subtract 1. So we have that okay. Sign checks out. Therefore, we get z equals to, by the way, negative first power. Let's take just one more. 1 plus t squared, like this. Let's write it like this. And then divide this one away, or multiply it away. I'm going to get 1 plus c, 1 plus t squared. Looks like that's what I'm getting. Is that right? I guess so. I guess that's what I'm getting. Multiply this one out. Okay, all right. Well, there's a good way to check. 1 plus c times 1 plus t squared. And then let's simplify this part. 1 plus t squared times z prime of t minus 2t times z of t plus 2t, this entire thing, and let Mathematica calculate it. Yes, I got 0. So everything here is correct. How about the next problem? This one I'm not going to complete. I'll just stop halfway through. Oops. First, make it into a standard form. So divide by t, so z prime plus dividing by t, what am I going to get? 1 over t plus 1. Z is equal to 1. Is that what I'm getting? Okay, so what is p? This is p. So the integrating factor will be q equals to integrate 1 over t plus 1 dt, and that's gonna be logarithm plus t, right? So t plus log of t. I changed the order because of the typesetting. Log of t plus t, and it's sometimes difficult to distinguish whether this is log of t plus t or a student missed parentheses or something. It's sometimes difficult to tell. And that's why I'm taking this a little bit safer approach here. And then what is integrating factor? E to the q power is e to the t plus log of t. And how do you handle this? I'm going to stop here. Okay. Here are some initial value problems, and please take a look at these problems here. They all correspond to all these. And we just did this problem. So why don't we go to this problem and complete it? I'll leave the others to students. Okay, all right. And what was the solution? We just did it. And solution was, yes, this was the solution. Okay, let's come back. So z of t is 1 plus c times 1 plus t squared. Okay, there I'm gonna put in the initial condition. Z of 0, plug in z equal to 0, t equal to 0, so I'm gonna get 1 plus c times 1 plus 0 squared, so I don't have to do anything here, times 1, still I don't have to do anything here, that's equal to negative 1. I'm getting c equal to negative 2. Did I do this right? Therefore, I'm getting z of t is 1 minus 2, 1 plus t squared. Does it look good? Well, there's one good way to check, because I'm using computer algebra system here. Z of t is defined as 1 minus 2, 1 plus t squared. By the way, in case you're curious about this mathematical coding, when you define a function, you need this underscore. If you use just z and then bracket, then that's not going to define a function. Once you define like this, and then afterwards, it's going to be just plain bracket. Simplify, and then let's simplify this whole thing. 1 plus t squared, z prime of t, minus 2t times z of t. You see, if I forget this times, then tz may look like just one variable. So in order to avoid that, I'm putting either space or the multiplication symbol. Simplify, and I can check whether this is a solution indeed. Also, I'd like to check if it satisfies the initial condition. What is z of 0? And z of 0 is negative 1. Yes, indeed, everything fits. As for the other, well, left to the students. Next topic is Bernoulli equation. Okay, I do not have enough time to start a new topic, so let's come back to, not this one. Let's come back to this problem and let's discuss it a little bit. Where were we? If I remember correctly, we were here. So that was the integrating factor. And then how do you work it out from here? Well, the typical technique here is something we already discussed in separation of variables part. When you have sum in the exponent here, you can always bring it down like this as multiplication. And then this one over here can be simplified into just t. So that's t times e to the t power. So that's the integrating factor. And then if I multiply the integrating factor here, what do we get? Let's see, what was the standard version? Z prime plus 1 over t plus 1z, which is equal to 1. That was it, isn't it? After dividing everything by t. So the left-hand side is z times the integrating factor, z times t times e to the t power. And then the right-hand side, I have to multiply integrating factor to 1, which is t times e to the t power. And what we end up with, we have an integration of this thing, and that can be done by integrating by parts. How to take care of this integral? Okay, now is good time to stop. The remainder of the problem is left to the students.